Hello, good day viewers. In this tutorial, I'm going to show you two different ways to differentiate an absolute value function. Let's start with the mother function. Suppose we have y to be equal to the absolute value of x, something like this. If y is equal to the absolute value of x, we all know that the absolute value of x can also be expressed as what? The square root of x squared. Something like this. The square root of what? X squared. But according to one of the laws of indices, we can write this one as x squared, but raised to the power of what? 1 divided by 2. So now we are free to apply chain rule to differentiate this function. Y prime is equal to, this power can drop down to multiply, then you subtract 1 from the exponent. So if 1 over 2 drops down, you multiply by x squared raised to the power of 1 over 2 minus 1 is what? Negative 1 over 2. But remember chain rule, you have to multiply by the derivative of the inner function, which is x squared. If you differentiate x squared, you have what? 2x. You see, by multiplication, this 2 and this 2 will cancel, leaving only this times x. But you can drop this down such that the exponent becomes positive. We end up having x divided by x squared raised to the power of 1 over 2. But what can you remember about this x squared raised to the power of 1 over 2? It is here exactly the same thing as the absolute value of x. And hence this is equal to x divided by what? The absolute value of x. And this is just the derivative of the absolute value of x. But you should know that, or you remember that, absolute value of x is a piecewise function, right? If you have your function f of x, which is this one, it is either x or negative x. It depends on the value, right? Whether it is negative or positive, the absolute value will always transform it to positive. So x is a variable. We don't know what it is. So it could be x or negative x. It depends on the value. So if it is positive, x is greater or equal to 0, or when it is negative, x must be less than 0, right? So you can see that if you are to differentiate this is the second method. If you are to differentiate this f prime of x, it is equal to, if you differentiate this, you have 1. That is when x is greater than 0 but not equal to 0. I will show you why. And if you differentiate this, you have negative 1. That is when x is less than 0. Well, let me show you why. When we take the derivative, we have to remove the equality sign. Remember how the graph of absolute value of x looks like? Something like this. It's a V shape, right? This is how the graph of absolute value of x looks like. It is continuous everywhere. You can see from negative infinity up to positive infinity. But look at this point where we have this sharp turn. It is not differentiable at that point, and hence we cannot use equality sign. If you say it is equal to 0, this is exactly where x equal to 0, and it is not differentiable at x equal to 0, and hence it has to be greater than 0. So you can see that the slope of this line is positive 1, which is this, and the slope of this one to the left hand side is negative 1. And the moment you simplify this, you have to obtain negative 1 or positive 1. If the absolute value of x is positive x divided by x will give us what? 1. And if it is negative, we have x divided by negative x is negative 1. So it depends whether to transform the function into piecewise function before you differentiate, or you apply this method. But let me show you another one from which we can deduce the final formula to use. Suppose we have a function y equal to the absolute value of x minus 2, for example. Let's do a kind of u substitution. Let u be equal to this x minus 2, such that our y will now be equal to the absolute value of u. Because I have let the whole of this to be equal to u, therefore y will be the absolute value of u. So let's differentiate these two functions separately. Here we have du over dx to be equal to, the moment you differentiate the right hand side, derivative of x is 1, derivative of negative 2 is 0, so we only have 1. And if you differentiate y, or let me call it dy over dx, or dy over du, sorry, dy over du, remember, we have differentiated the absolute value of x, where we obtain x divided by the absolute value of x. So it will be the same thing here. It will be u divided by the absolute value of u. So what will be dy over dx, since we are looking for the derivative of y with respect to x? Dy over dx will now be equal to du over dx, but I can start with this one, dy over du multiplied by du over dx. Remember chain rule. Du and du will cancel. We end up having dy over dx. So let's substitute. This is u divided by the absolute value of u multiplied by du over dx is 1. All we have to do is to back substitute. U, remember, is x minus 2. So therefore dy over dx is equal to u, which is x minus 2, divided by the absolute value of u, which is absolute value of x minus 2, multiplied by 1, which we don't have to. So you can see that the derivative of the absolute value of x minus 2 is equal to x minus 2 divided by the absolute value of x minus 2. And remember, you can always transform it into piecewise function. And if you do that, you differentiate them separately. And remember, from here, you can even split it. This could be positive or negative. If it is positive, we have x minus 2 divided by x minus 2, which is 1. If it is negative, x minus 2 divided by negative x minus 2, which is going to give us negative 1. So in general, you can always take the function inside, divide by the absolute value of the function, then multiply by the derivative of that function. Let me give you an instance. If y is equal to the absolute value of 2x squared minus 3x, for example, y prime is equal to, you see, the function inside, that is 2x squared minus 3x, divided by the absolute value of that function, 2x squared minus 3x, multiplied by the derivative of the inside. If you differentiate this, you have 4x minus, differentiate 3x, you have 3. If you like, you can take this and multiply by this. If you so wish, you leave it like this. So you take the function inside, divide by the whole function, which is the absolute value of the function, then multiply by the derivative of the inner function, and you're done. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.